welcome back to Algebra 1. The first thing I'd like you to do is pause the screen, do the 3 problems that you see here. There are slight issues with every one of these, and then we'll come back. Okay, now that we're back, there's a couple little things that we see here. One of the things is I might have to distribute from the back. There's nothing wrong with that. In this case, I have negative 16x and positive 28. Okay, I can also distribute something that has a negative sign. And there's nothing wrong with distributing fractions. When I distribute fractions, I often like to do the division first because it will give me simplified numbers. 8 does divide by 2, that's 4. 4 times 3 is 12, negative 12x. 16 divided by 2 is 8. 8 times 3, that's the 24. And that one has my y. I can also distribute to more than 2 terms. You just keep going. Every one of these has the 4. Now, I also do notice that these two guys happen to have the same term. So I could distribute first and then combine like terms, or I could combine like terms and then distribute. Both ways work. In this case, I'm going to show you that it's 4x minus 12, x plus 20, and my last step would be combine like terms. These two end up giving me negative 8, x plus 20. All of them are just little things that we have to watch for in distributive property. So the next thing that we're going to be doing is multiplying 2 polynomials, and there are a couple different ways that I want to show you. We use both of them, we interchange them, doesn't matter which one we use. The first method, we want to take the things that are in the first term and we have to distribute them to everything in the second term. So the x gets distributed and the 2 gets distributed. So in this case, I have what we have in green, then what we have in blue, and then after we do each of those distributions, we are going to combine like terms. 5x plus 2x, those combine to 7x. Notice that we have this written in standard form. The second method is sometimes called the area method. When we get to larger problems, I call it FOIL on steroids. But we have a box, and on that box we have both of the variables written on. One variable is written down. Notice the negative sign goes with the 4. The other variable is written to the side. If there are negatives, they're always written with the term that they are involved with. And then it's a times tables. We multiply everything. X times x is x squared. X times 3, 3x. Negative 4 times x. And negative 4 times 3. And then we combine like terms with everything in the box. What you'll notice is this is where we tend to need to combine like terms. That's where we're going to watch for it. Both of these methods are perfectly acceptable. You will often hear me say the word FOIL it. So in FOIL, F stands for multiply the first terms, so the x times x. O stands for the outside terms, outer, outside. I stands for the inner terms, and L stands for the last terms. With every single one of these, we are always watching signs. In this particular problem, they're all positive. So we have each of the separate ones written out, and then the last step is combine like terms, which gives us our 3x. Typically, the outer and inner are the two that will give us terms to combine. Not always, but usually. So in FOIL, we tend to draw the picture that looks like this, and we're now distributing the 2x on the top and the bottom, and the negative 3 on the top and the bottom. I also call this eyebrows. nose, and mouth. Each of these terms is separately done. First, outside, inside, last, combine like terms. Okay, so when we do this, we need to watch out for our negative signs. So our firsts, z squared. Our outsides is positive 6z. Our insides, keep track of the negative sign. And our lasts, negative 12. Combining like terms, we're going to end up with 4z in the middle. Notice in FOIL, outside, inside are the two that combine. And we also will get it set up in standard form. If we want to show our second method, always more than one method to use. I'm going to have a box that is 2 in one direction, 2 in the other, because each of my variables, I have 2 terms on this polynomial and I have 2 terms on this polynomial. The negative goes with the 8. I'm going to fill in the multiplication square. Z squared, negative 8p, 3p, and negative 24. When I combine like terms, it's these two that tend to combine. So writing it in standard form, I'm going to look for my highest variables, then my next degree, and last my constant. Both methods work equally well. If I'm going to FOIL this, I'm going to start with my first terms, my outside. Negative times a positive is a negative. I don't necessarily need to write that negative 1, but I do need to write negative r. Insides and last, negative times a negative, positive. Combining like terms, negative plus a negative stays negative. I add the numbers, keep the sign, and there we go. Both methods work equally well. This is the first example where I actually have a binomial multiplied by a trinomial. So I could FOIL this out. I would call that FOIL on steroids. The x has to be distributed to 3 terms. And the 5 has to be distributed to 3 terms. So it's a little bit more careful to watch how we do that. By the time we get 3 by 3, you have to be even more careful. Each term in the first polynomial needs to be multiplied by all of the terms in the second polynomial. So this is really where the box area method really shines. So we have a 2 by 3 term polynomial. That's going to give us 6 different boxes. And what we'll notice in those boxes is this direction tends to be where I combine like terms. And I do that in the step. I don't write them all out. I go ahead and do negative 3x squared plus 5x squared is 2x squared.